Hi, so today we are doing 223 rectangle area. Problem statement is pretty simple. All we gotta do is calculate the area of two overlapping rectangles. They might be overlapping, might be not, but we have to calculate their combined area. So, for example, this rectangle and this rectangle have to be calculated, and then you subtract the area of the rectangle that is overlapping between the two, and then you get the combined area, and that's your solution. Pretty simple stuff, and also pretty simple solution. But first, let's look at the first solution, which is presented by Big DOT. As you can see, it works, but it looks like this. So the calculation for the first area and the second area are pretty simple. You basically just subtract the so here, for example, ax2, you subtract it from ax1, and then that's your length, and your height will be done the same way. So ay2 minus ay1, and that's your height. You multiply those two, get area 1. For area 2, you do the same thing, but for b values. Mr. OT decided to change the variables to a, b, c, d, which made it even more complicated, since now you don't even know what variable belongs to which, but whatever, we're going with this solution for now. Problem is with calculating the third area, which is the area of the small rectangle overlapping here. So if you don't want to do it easily, you can do it this way, which is basically you check each and every case. So if area 1 is equal to 0, you turn area 2. If area 2 is 0, area 1, so on and so forth. And if all the areas are the same, if all the values are the same, like between triangle 1 and triangle 2, you return area 1. If all the values are different, then there's no overlap, and you return area 1 plus area 2. And it gets even more complicated. But as you can see, this is not the right way to go about it. I mean, that's 70 lines of code when it could be solved in one line. This is by MD 2030. It's pretty simple. You calculate area 1 the same way, area 2 the same way, but for area 3, you get the minimum between the right side. So here, the minimum between ax2 and bx2 is bx2, obviously. Is ax2, since ax2 is 3 here and bx2 is 9. Then you subtract it from the maximum between ax1 and bx1, and you do the same thing for the y's, for the y values, and that's your third area. Then all you gotta do is return the first area plus the second area, subtract it from the third area. You can even make it smaller, the number of lines of code, I mean, oh, sorry, not that, by just doing it this way. And it's the same value, just less clear on what's happening. I like to use variables, so whatever. And that's your answer. That's all. Bye-bye.